Okay, so I'm going to give you one possible solution for the quiz from Tuesday. Some of you did preferred to make to row operations until you had an echelon form, and and then you had to just take the diagonal elements, which is of course fine. But if you do it that way, it's harder. It involves more fractions and so on. So I want to show you a way that I think is the least, where you have to do the least kind of bad numbers, and it's not always possible, but it's good to try to analyze how to solve such a determinant. Okay, so what we should look for always first, I think, is rows or columns with a lot of zeros. To be more precise, everything zero except for one element. And that's the case here. We have this column here. Because then it's easy to do an expansion. You should never really consider doing expansion when you have more than one non-zero element in a row or in a column. So I'm going to do that. So that means I'm going to use column 2, and I'm going to expansion. Now, of course, that means what? Well, that means that I have the factor 3. Sorry. The factor 3, that's the factor. Now, the cofactor is obtained by deleting row and column. But we also should take into account that there is the issue of a sign, right? The cofactor always comes with a sign. And so in this case, it would be a plus, minus, plus, minus. So we have a minus sign here. And what we're left with then is this determinant 4, 8, 10, 2, 1, 2, 3, 0, 3, 4, 4, 4. Oh, no, not that one, because that one we erased, right? Okay. So 0, 3, 1, negative 2, and negative 1, negative 7, 4, 4. Okay. Now, there is an advantage, because we're taking the determinant, we do not really need an echelon form. So what we want is a column with a lot of zeros in it, and so therefore I can use this as a pivot, and there's no need for me to place it to this top row. You can, but don't forget that when you switch to rows, the sign of the determinant changes. Since I don't want to deal with this kind of extra complication, I don't do that. So I'm just using that as a pivot, and I'm going to try to make these two guys here 0. So the two row operations that do this would be row 1, replace row 1 minus 4 times row 2. I'm working with row 2, right? Because that's where the pivot is. And row 4 plus row 1. Okay? So I get negative 3. Don't forget to copy the factor that you have. And then the first row, so we do here with negative 4, and then add up. That's 0, 0, minus 2, 2. Right? And that row gets copied, and so is the next one. And then finally, I'm adding this row to that. That's just 0, negative 5, 7, 4. Notice, by the way, I remind you that these row operations do not change the determinant. So that's why nothing else. I don't have to keep track of these numbers negative 4 and 1. They don't play a role at all. Okay, so we have now our pivot, and means that we should use this column 1 again, this time to do the expansion and take care of the sign. That's a negative sign. So we get a negative from the sign. We have already negative 3, and then what we're left with is this determinant 0, negative 2, 2, 3, 1, negative 2, negative 5, 7, 4. Okay. Now this one, I admit I gave it a little bit harder. Originally I didn't intend to do this, but okay, it happened now. It's not that it's much harder. We have no 1 in the first column. Now some of you divided by 3 or by 5, and to make a 1, that's definitely correct, but it introduces a fraction, but it was not a bad thing. So sure, by all means do that. You also could notice that you have the 2 here that you could factor out here, or even there. I'm going to do just in the first row, so I'm going to factor out 2 from row 1. Okay, so what do I have then? Remember, I still have the 3 here, and then I have 0, -1, 1, 3, 1, -2, -5, 7, 4. But we have factored out the 2, so this extra 2, I'm going to do this in a different color here, right? Comes also out. So that's the 2 here that I factored out. Okay? Now, and so what some of you then did at this point was, for instance, expand this determinant along this row here, which is fine, 2 non-zero elements, but it's just luckily just 2 by 2 determinant, so it's not that much work. But you can also do, you can use this one here as a pivot to make zeros here. We normally used the first column, but there is no reason. Remember, we did here an expansion column 2, right? So why not use this pivot to make these guys 0? Okay, I prefer to use row operations. In fact, you can even use column operations, but let's not go there, because it gets always confusing when you can do this and when can you not. So I'll rather stick to row operations. So just using row operations, the ones that I have in mind therefore are row 2 plus 2 times row 1 to get this guy 0, and row 3 minus 4 times row 1. Okay, so what we get, so 3 times 2, that's 6, and then we have the first row doesn't change. Then we multiply this with 2 and add, right? So we get 3 minus 2 plus 1 is -1, and then 0, of course. And then the other one is now we multiply with -4, and that means -5. -4 times -1 plus 7, that's 11, and then we get 0. Okay, and so we can now do expansion in row 3. Column 3. Right? Why not row 3? Well, I could do that, but why would I then? I need to do 2 non-zero elements. So in column 3, that means I have this 1 here. What's the sign? Well, you might see this already, but it's a plus, okay? So we have this plus, I'm going to write it, 6, then the one that we don't, this factor 1 doesn't play a role, and then we have left 3 minus 1, -5, 11. And this is 2 by 2. 2 by 2s we always just use the formula. It is 6, this product is 33, this product is 6, what I'm saying is 5, right? And then we subtract. Don't forget that it's subtraction here, right? So we get 6 times 28, which was 168, which most of you had. Okay, that was it. There are other ways, as I said, but as long as you got to this answer, then I think you did it the right way.